This video is going to teach you how to do problems that deal with Charles' law. Charles' law is the second individual gas law that we're going to study. Charles' law deals with the variables of temperature, T, and volume, V, okay? The important thing, and this is a big deal, you must convert all of your temperatures to kelvins if they're not given that way. So make sure you note that. Must convert all temps to Kelvin. If you've forgotten how to do that, you can watch the first video on temperature and pressure again, or just remember that from Celsius to get to Kelvin, you simply add 273. Now, if temperature and volume are the two changing variables, then the items that we will hold constant are pressure, P, and the amount of gas in moles, or N. The equation that we would use is that V divided by T is going to give you a constant K, only if temperature is in kelvins. It's really important to remember that. Now, yesterday we learned that P times V equaled a constant K. This is a different sort of relationship. Basically, and think about what you know from your own experience. As the temperature increases, the volume of the object would increase as well. You might have seen this happen with, for example, a bunch of balloons, like if you buy balloons for somebody's birthday. If you take them and fill them in a normal room temperature room, but you bring them outside in the cold winter, the volume of the balloons shrinks because the temperature went down. But the minute you bring them back inside a warm house, they're going to expand again. So when the two variables both go in the same direction, if temperature increases, volume increases, we call that a direct relationship. That is different than the relationship we studied yesterday, but that's how volume and temperature are related. So we're going to try an example problem. A sample of gas occupies a volume of 230 milliliters. Now, it might be helpful if you're really kind of still shaky on these problems to go through and underline what the variables are. Milliliters means volume. Degrees Celsius is obviously a temperature, and 750 torr is obviously a pressure. Now, the question's saying what volume will it have at 20 degrees Celsius? So now our temperature is changing, but our pressure hasn't changed at all. So our variables are really only the volume and the temperature. Those are the only two things that are changing. Now, if you want to do this the same way we did our problems yesterday, or with Boyle's law, you'd make a chart. Volume and temperature. The volume that was given first is the 230 milliliters. Now that occurs at a temperature of 15 degrees Celsius, but it's not okay to use Celsius temperatures in our problem. We have to convert that to Kelvin. So we're going to add 15 plus 273, and that's going to give us a temperature of 288 Kelvin. Now, the question's asking us, what will the new volume be if we change the temperature to 20 degrees Celsius? Which, again, we can't use Celsius. We must use Kelvin, so that's going to be 293 Kelvin. Now, if you look at your relationship, the temperature is going up. If the temperature increases, so should the volume. So you're going to start with your volume of 230 milliliters, and you're going to multiply by the fraction that makes this go up. We want the volume to increase. If we want this number to be bigger, we want to put the big number on the top and the small number on the bottom. And when we do our math, kelvins will cancel, and we should end up with an answer of 234 milliliters. There's your answer. Now, what I would suggest you do is do the practice problem right now. Don't forget to change your temperatures to kelvins. Get your answer, and then that will be your learning practice problem.